Okay, now we have a quantifiers. Quantifier means that for all and there exist. You have these words, and both of them, they are very important during the solution, especially in the proof method. Later, we have proof methods. We have many things for proving things. So during that one, we depend on the for all and there exist a lot. That's the first. The second, here, the negation of them also important, and the order between them. So we have two things here. Yalla, there you go. You can see from here, we have what? We have, let P denote any statement, P. For example, your statement is what? X greater than 3, for example. That's a P, your statement. What's the P value of what? F of X, P of 4, and P of 2. You know, when you say P of 4, means that 4 greater than 0 is true or not? True. How about P of 2? 2 is greater than 3. So that one is false. So P can be any statement. Okay. Now, we can say from the, this is actually the predict, sorry, not quantifiers. Here also the predict does something to institute. It means that you substitute them, then you will tell me the answer, the result is true or false. For example, we have two variables. We say Q of X is the statement. So Q is what? Is X equal to Y plus 3. So tell me about the Q of 1, 2, Q of 3, 0. Means that which one is true, which one is false, show me. So when we say Q is equal to what? Here we say what? You can change that on to say X minus Y equal to 3. Am I right? So put the value 1 and 2, substitute one by one. So what's your duty? Your duty to substitute, just that's it. Okay, substitute and tell me your substitution is true or not. So if I have such thing like that, if I have such thing like that, such a statement, like, look, like X minus Y equal to 3, and this is your Q. So please tell me about that one is true or false. So I am going to put in 1 minus what? Minus 2 is equal to minus 1. Of course, minus 1 is not equal to 3. So that one will be false. How about the other statement? 3 and 0? True? Good, true. So that one is false. That one is true. That's called predicting. Okay, dears? Clear? Good. Now quantifiers. Quantifiers, as we say, for all, we have this symbol, also sometimes called domain of discourse. It's called for all, like A and upside down. Okay, like A upside down. There was a seminar on the mathematics, and we have a guest. We talk about for all and there exists, and later we asked them, how was the seminar in mathematics? He was, wallahi, it was very good, very nice. But I don't know why they wrote A upside down. So that one's not A upside down. That's what means for all, okay? So when you saw that one, it's for all. When you saw that one, means that there exists. For all is the generalization. For example, I say characterization of things. For example, I say, from today, all computers will produced with the Windows 11. So when I say all, I mean all things. All those computers belongs to the Microsoft's company. You know what I mean? When I say but, we make extension, exception. You say but the old one may be 11 and 11 or 10, Windows 11 10. So when you say maybe there exists one of them is 10. When we say they're older computers, means that if you check whole company, you are not going to find any, even one single computer which with Windows 10. Understood? When you say for all. When we say there exists, maybe I say here, maybe if you check the other room, maybe there exists markers. Okay, so you are going to that room, there is no. You are going to the room number 100, classroom number 100. There is no. You are going to up. You will find in one room there exists one. If you got at least, let me say, sorry, at most one of them, so means that there exists is happens. So that's the difference between there exists and for all. Did you get the idea? For all means that there is no gap. There is no way to not be like that. When I say f of x, for example, equal to x or polynomial, if p of x is a polynomial, means that axn plus an, any numbers, if we say for all polynomials, the domain is R, means that you cannot find even single example which contradict to my word. Understood? When I say for all students will pass, means that there is no student has not passed or failed. Understood? But when we say maybe there exists one student or two students failing this course, maybe there is one of them, that's enough. So for all is a strong condition. When you say for all is this very strong condition. I say for all x belong to R, means that each single number in R. When I say for all x belong to Z integer numbers, means that all positive integer, negative integer, and zero. Understood what we mean? Hello? You got it? Very good. Well done. So that's what we mean by positive and negative and zero. Okay, dear? Good. Now here's the quantifier. We can see for all, xp for all means that, what do you say? We see it's called for all, called universal. It's called for all, sometimes called universal quantifier, means that which is false is called counterexample. If you bring, for example, if you bring one example which is not true, so that example is called counterexample. For example, I say all students here are from engineering. All students in this course, in this room, are from engineering. If I get one single student which is not in, so this number, this example is called counterexample. Okay, dears, which make our universal things to be unright, to lose the generality, to be false. Understood? Good. So we have universal quantified for all. We have the existent quantified, single one. We have counterexample, which make a for all different things. You got it, dear? So you can see from here, it's called for all. For all is true or false. Good. So you can see how we read that one. We say P of X is true for every all one, yeah? For all, for every X. How about that one? There is an X, one X, an X, okay? Which is P of X true, okay? There's an X with P of X true. For example, this course is for both engineering and science computer, right? So for example, if all of you from engineering, but there is one student from science, is that statement true? Yes. Why? Because I say there exists one student which make it happen. So that's called what? It's called there exists. And you can see there's a negation of it. Negation of all is what? I told you, if you say for all students from the engineering, if I bring a single one, that one will make us the false statement. There is an X, right? Single one example. How about here? It's false. I say there exists one student from here. No, if I say is not, my talk is not right, my statement is not right, means that for all is false. To understand these, especially this part, is called, let me go to the, for example, go to here later, go to the negation of 1, then you'll understand. Look, negation of for all is what? You can see. Look at here, please. Negation for all is what? Is there exists X not belong to P. How about negation for there exists? You have negation for all X belongs, for example, be in P, or you can say negation of for all X, P is true. Okay, I can say there exists X, P is false. Understood, dears? Hello? Good. How about the reverse of that one? If I say I have there exists X, P of X true. If I change that one to negation, if I take a negation of that one, so I say what? Yalla. There exists will change to what? Kaka? No. There exists what? We'll make that one for all X, P is false. Understood? So they are inverse. If you take an inverse, you can see it will change to the other part. Let me go to the example to understand the summarized things, not a part. Okay, here's the example. Let Q be that statement. What is the true value of the quantifier like that? Where the domain consists all real numbers. That's a question. So how we understand? Q, what's the statement? Q is what? X less than 2. Okay, where this one is true? We say for all X, X be in where? No, smaller than 2, right? So X smaller than 2 means that start from 2 till where? Yes, negative infinite to 2. Now you understand, right? So where is the false? 2 to infinite. Understood? So for all X, that one is true or not? That statement is true or not? True. Good. So how about generally speaking? For all X, X belong to the real numbers. Tell me, this statement is true or false? For all real numbers, all universal real numbers. Huh? Of course, false. Understood? So generally speaking, if I want to answer this question, what was the question? You say what? Let me highlight it. Yeah. What is the truth value? Okay. Where what? Where domain consists of all real numbers. Means that you have a Q X less than 2 for all X belongs to a real number. Of course, that one will false. Why? Because at least I have 3. At least. I told you, if you want to make the for all to be false, at least bring one example. 3, which is not greater than 2. Last example. Let me see for existential. That one for existential means that there exists. No, we don't have an example here. So we try to find one if there's chance. Yeah. That one's compound. This compound between them. Later, I'm going to bring more example. We stopped here. Thank you for